Hi everyone, today we'll be discussing the LeetCode problem of the day, triangle. In this question, you are given a triangle array and you have to return a minimum path sum from top to bottom. For each step, you may move to an adjacent number of row below. If you are on the ith index, then from that index, you can only move to either index I or index I plus 1 of the next row. For example, if you are at index 2, if you're at this 2, you can move to 3 or 4 of the next row. And suppose if you're at 5, this is row 0, this is row 1, row 2, row 3. Now this 5 is at index 1. So from this 5, you can move to either index 1 of the next row, or you can move to either index I plus 1. So index 2 to the next row. So in this question, at the end, you have to return what is the minimum sum path from top row to the bottom row. So if you take a path like this, if you take 2 and then 4 and then 7 and then 1, so this will give you a total sum of 12. But you can also take a path like this. You can go with 2, then 3, then 5, and then 1. So if you take this path, the total sum will be 11. So we can say that this is the least sum possible. So you just have to return 11. Let's go with the second example as well. In the second example, you only have one row and the value is 10. So you start from here, you end here, and the sum will be minus 10. So you return minus 10. Now coming to the approach. So you can start from 2 and you can take any path to reach the bottom row. So if you take this path, you will end up in the first index of the bottom row. And if you take like this path, you will end up here. And if you just take this path, you will end up here. So we can't say for the final answer, for the final minimum answer, which index of the last row we will end up at. So what we can do is we can try to iterate from bottom to top, because at the end we will end up at this 2. So that means suppose we are at 4. So from 4 we can reach 6 and 3 and 2. And suppose we are at 1. So from 1 we can either go to 6 or we can go to 5. And once you are at 5, you can either go to 3 or either go to 4. And then from 4 you can go to 2. So at the end, whatever answer you will have here, that will be your minimum answer. So for this, first let's iterate. Let's start at the last row and iterate these values in pairs. So first you are at 4 and 1. So if you see this 6, from this 6 you can go to either 4 or you can go to either 1. So since you want the minimum sum, just take the minimum of this 4 and 1 and add it up in 6. So my original value was 6. Now it will be 6 plus minimum of 4, 1. So it will be 7. Now go to the next pair, which is 1, 1 and 8. So from 5, you can either go to 1 and you can either go to 8. So just take minimum of 1 and 8 and add it to the 5. So 1 plus 5, it will be 6. And do the same thing for the last pair, 8 and 3. Minimum of this is 3 and add it to 7. So this will be 10. So what this 6 represents is, suppose our tree is stopping here. So from this number, if you start and if you go to the bottom, this value will be the least value. So we can see that from 5, if we go to 1, the value will be 6. Similarly for 7, if we go to 3, the least sum will be 10. Now once this row is completed, we'll move to the previous row. Now again, we'll see this value and this value. And then from these 3, we have 2 choices. We can either come here or we can come here. So again, we'll take minimum of this 7 and 6 and add it to 3. So 3 plus 6 will be 9. Now we do the same thing for this pair, 5 and 7. Minimum of this new values, minimum of 6 and minimum of 10 is 6. So 4 plus 6 would be 10. And at the end, finally we move to this row. So we are at here. Minimum of 9 and minimum of 10 will be 9. So 9 plus 2 will be 11. So now here, this 11, what this 11 represents is the least path from the bottom row to the top row. So that basically means the same as the least path from top row to bottom row. So the 11 is the final answer. So in this example 1 also, we have the final answer as 11. Now let's go with the code. So like we discussed, we are starting from bottom and we are building the top, building the answer to the top. So at the end, our answer will be at the top. So we can simply return triangle dot get 0th row and 0th column. Now before this, we just have to fill our answer from bottom to top. Let me just take the size. Let's start iterating from bottom to top. For int row equal to n minus 1, I less than 0, I minus minus. We will iterate row 3, row 2 and row 1, because from row 1 finally from this and this we will able to reach 2. We won't iterate row 0 because this is where we have to stop. And for each row as well, j equal to 0, j less than triangle dot get row dot size minus 1. And in each row as well, since we're iterating in pairs, so first we will iterate on 4 and 1, then we'll iterate on 1 and 8, then we'll iterate on 8 and 3. So we just have to iterate till the second last element of each row, because if we iterate at 3, then we don't have 3 and the next number, it is out of bound. So now we have the 2 elements as j and j plus 1. So let's first get the minimum value of both of this. Math.get triangle dot get row. Let me just use column for this variable. Column. Math.get triangle dot row dot get column and math triangle dot get row and then column plus 1. So in these 2 elements, whatever is the minimum, we have to add it to the previous row element. So now we got the minimum, and let's just add it back in the previous answer. So triangle dot get row minus 1 dot set the index will be column only, and the value will be the previous value plus the minimum value of this. So the previous value we can get it by triangle dot get row minus 1 dot get column. So this is a bit lengthy. If I expand it, yeah. So triangle dot get row minus 1 dot set. We will set the column, and the value will be the previous value plus the minimum of the current values. And yeah, this is the step we'll repeat for all the rows from last row to the first row, and at the end we'll just return the top element. Okay, I think I need to add one more bracket here. Okay, sorry, this is math dot min, and this bracket is ending here, so the set bracket should also end here. Yeah. And this is row. We submit. Now finally coming to the time and space complexity analysis. For the time complexity, we are iterating all the elements in this triangle except the first row. So basically the time complexity will be the total number of elements in this triangle. So we can see that triangle length is 200. So in first row we have one element, and in second row we have two elements. Like until in the 200 row we have 200 elements. So the total time will be sum of all these values, 1 plus 2 plus 3 up to 200. So we can have 200 into n plus 1 by 2. So this is the total number of elements in this triangle. So we can say that if the triangle length is n, then the complexity will be order of n square. And for the space complexity, we are not initializing any extra space, so space complexity remains order of 1. Here we will denote that n is number of rows. So at max it can go 200 into 200 plus 1 by 2. So I think it is 2 into 10 power 4. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.